Yes, Rituja, Kajal, are you there?
Yes, ma'am.
Okay. Okay. In the last class, we have studied about the expression for code generation for expression. So code generation for expression, how it was, I think you all have seen one algorithm which I have shown, the skeleton of the algorithm, which was before going again the same skeleton of the algorithm. Uh, just recall in the previous class what I have told. In the previous class, I was been explaining about the code generation for an expression. So how was that expression? I had some expressions, something like a plus b, and also c multiplication with d, and a multiplication with the b, and also sorry, we had two expressions, that is a is multiplied with b, and c is multiplied with d, and both generated the intermediate code, both generated the intermediate code, and both were again added, both were again added. So we have seen how the intermediate code was generated. Now if I go with the same example, like a multiplication with b, and meanwhile we should also concentrate on how the code is generated. Meanwhile, we should also concentrate on how the code is generated. And you may be knowing that the code has been generated using the operand descriptor and also the register descriptor. And I have told you the how is the format. Can anybody tell how is the format of the operand descriptor, which I have displayed here itself, operand descriptor, and not only the operand descriptor and the register descriptor. Before going to the register descriptor, let us know the operand descriptor, and that operand descriptor which we had in six code, in six formation of code, or six ways of intermediate code was generated. For this, the a is multiplied with b, and c is multiplied with d. And how this code was generated, you may be knowing the abstract syntax tree. Are you all are aware, which you have studied in your C class? Sorry, object oriented class. May I know anybody? Means you, how is this the depth of this? How does it causes? And how is here the syntax is recognized? And how does it generate the tree? How does it generate the tree? That is based on, and what is this tree which is generated for the which is generated for the expressions, and what kind of expressions we have the expressions like loop expressions are there, if expression is there, while expression is there, and we also have the simple expressions like a plus b or a star b, that is a is multiplied with b. So such assignment expressions also we have. And how does it recognizes, how the parser recognizes the expressions, and the parser will recognize the different expressions, and it put them under different categories based on the identified tokens, based on its identification of the token. If the token is if the token is having something like assignment, or if the token is something like left bracket or the right bracket, once it sees the left bracket it has to see the right bracket, then only it can assume that it is a function, then only it can assume that it is a function. Or something like in a expression, it assumes that it has to be done at the first level, that is the preference will be given at the first level. So, and so we have expressions of different kinds. How many expressions we have means we have different kind of expression, so that the compiler has to understand. Like expressions can be assignment expression. I'll write here assignment expressions. And not only the assignment expressions, sorry, first let me tell here as expressions. So here what we are studying in the sense, we are learning since from the past week, we are learning about how the code is generated for expressions. How the code is generated for expression. We have assignment expression. Not only assignment, again, last week example which was resembling something like assignment expressions, something like I have given you a plus b. Another expression was a plus b. Another expression was a sorry, uh, I think it was a star b. Let me check out what the example which I have given in the previous class. In the previous class, it was a star b, and that was added with the another term of the multiplication, that is c is multiplied with d. C is multiplied with d. So this was added with c is multiplied with d. And you must be very careful that compiler how the compiler recognizes the preference operators here, or how the compiler will understand that what the expression or which type of the expression should be executed first, because the compiler recognizes, as it sees a, it recognizes that it is an operand, and as it sees or as it see another next token, that is multiplier, the next token operator is multiplier, and it recognizes that as the multiplier token and puts that into the category of the C or the tokens, that is operator token, arithmetic operator token, and as it sees B, it understands that B is an identifier, and as it so now with this, what does it has to conclude, because still the token is in pointing to, it is pointing look ahead, what it is doing, still the token it is pointing look ahead, from as it is traversing from left to right, from left to right. So still the token, sorry, still the pointer is pointing, means it is something like look ahead. So it is, but till here what it has to assume, till here what it has to assume, once any left operand is finished, once any left operand is finished, it has to see something like the expression operator, it has to see something like the expression operator. So once the left operand is seen, it has to see the right operand. That's what here the tree is, abstract syntax tree is constructed. How the abstract syntax tree is constructed means, it assumes this as the, for the operators it assumes it as the it as the expression. For operator it assumes it as the expression. So whenever an operator is seen, it assumes it as the expression, and here also there is an operator plus. So how it has to do, so it has to do in the sub expressions manner, it has to do in the sub expression manner. Yes, the screen is audible, anybody? Yes, Rutuja, Kajal, Sonia, Saloni. Okay. If any disturbance, do acknowledge me. I will just verify it by relogging. So here, what we are learning? We are learning about the code generation. What we are learning? Code generation for expressions. What expressions it can be? Many more expressions, because in a in a language, or in that language is nothing but a compiler, not a means a compiler accepts particular language. So I must say, any program which you want to solve it, you come across various type of the expressions. You come across assignment expressions. You come across not only assignment expression, that is the one, and maybe you will be coming across the for loop. Then you might come across while loop, and you might come across, because these all are nothing but the programming technique which are used in not every language, which are used in the language, which are used in the language for making our requirement, how we want the target of our program or target of our project that has to be executed. So we require all such expressions. So every any language, whatever we are opting, maybe we come across some expressions, maybe we come across while loop, maybe we come across do while loop, also we come across conditional statements, also we come across conditional statements, and those conditional statements can be those conditional statements can be if, simple if, also if else, then ladder if else, many more. It all depends on the type of the language. And if at all, do I have left anything? Yes, anybody? Do I have left any expression? I have come across for loop, while loop, conditional statement. Yes, anybody? So these also are nothing but the these all are nothing but the expressions which builds the language, or which builds your any programming code which you wanted to do, making use of these expressions, making use of these expressions. So in the previous class, we have seen only about the expression called as the assignment expressions. It was something like A star B, and it was added with another sub expression C star D. Another sub expression C star D. And I have also told you how is the algorithmic code of that. We have also seen how is the algorithmic code, and we have also seen how is the parse action of that. First, it recognizes as the token it sees, it recognizes this as an expression. What expression it identifies? First, because it makes the precedence of operator here. It make use. So according to the precedence of operator, first it has to solve the A star B. Next, it has to solve another term P2, that is C star D. Then the third term can be the entire expression, which is the third time, So only here, and meanwhile it also generates the code. How does it does? So here the expression plus is assigned to multiplication here. First one, what it is? The expression plus is assigned to multiply here. But if I go with the sub expression, the star, I must show here the arrow mark. I'll just draw here the sub expressions so that you can understand how it is the sub expressions which I am showing you, and it is also something like abstract syntax tree. So this star, what it is doing, I must take this under the circle, but here circle drawing everything, it goes something like very tough for me. Again, I require otherwise I require more number of sorry, here the objects to create all those things. So here the first assignment here is, or the first assignment operator here in this part, it is star. So it identifies the star as the operator. Which operator? Assignment operator. Assignment operator. Then this assignment operator is multiplied by a. So here is multiplied by what? Is multiplied by a. So I must go in this way. So here I need to make here round for a star, round for star. The entire font size I'll take bigger. So a. Next it is uh, next it is multiplied by b. A is multiplied by b. But how do we call this? What do we call this? This is nothing but something like abstract syntax tree. This abstract syntax tree is identifying the expression, and in this way it does the parsing also and generates the code also. So here it's showing ups and down. So because of actually I wanted to show like this. It is b, a star b. So here I can name it as t1. Here I can name it as t1, and this t1 is nothing but the something like sub expression. But this is all the human being, we the user, I am doing in this way. But how does the compiler understands that in this way? The compiler does according to the operator precedence. Operator precedence. So the operator precedence, first it has to solve for the plus minus, sorry, first it has to solve for the multiplication and the division, then it can see for the plus or the minus. It can see for the plus or minus. So here again, as it is moving from left to right, again it is observing here something like plus. So this plus is nothing but again an assignment which whole this sub expression is treated to be as the left value. Whole this sub expression is treated to be as the left value. So this whole sub left value, just I will show here something like this. Whole it is treated to be as the left value, as this assignment operator multiplier was having. Multiplier operator is a assignment operator and its left value is a. The left value again, it is nothing but a literal expression. What is this? Here everything is treated to be as an expression. It can be for loop, it can be while loop, it can be conditional statement. And in a conditional statement you have the you have what again the left bracket and the right bracket and the body of the conditional statement, and the body can be body can be if simple if body, or it can also be the if else body. So in that if else body again, it can see the expression also. So in this way it treats every whole code as the expression, whole code as the expression. Now I am treating this operator as the expression. I am treating this operator as the expression. So what is its left value is a, what is its right value is a. Of course these are called as the literals. What these are? Literal, left literal, right literal. So literal, obviously it will they will not have further nodes, they will not have further nodes. So every expression will have a left and right, therefore it is called as a tree, therefore it is called as a tree. Abstract syntax tree. Now here this is having again the plus. This expression is assigned by plus. This expression is assigned by plus. What is the plus left value? The plus left value is whole of this abstract small sub expression. And what is the right sub of this? I'll just copy this. Now the plus becomes here the expression. What is the left sub expression? The left sub expression is again an expression. What expression? Multiplier. Multiplier is an expression. A is multiplied with B. Then this assignment, the plus assignment, this assign, usually we call them as the binary. Why we call them as binary? Every expression is treated to be as an binary. If you go with if statement, if has got, what is the binary of the if? Actually the binary of the if is said to be as the type. It can have like less than, greater than. So all these are nothing but the less than, greater than, the less than or greater than the operand, the operator in between the left and the right operand, in between the left and the right operand. So here everything is treated to be as an expression. So based on the left and right operand, that's what the code generation describes the operand descriptor and also describes the register descriptor. Why register it make use of the register? It make use of the register because it has to store the computed or the evaluated value in the register. Unless it does in the, unless it stores in the register, and later in some cases it has to free also. So whatever is the status of the register, which we have seen in the previous class, and so that status of the register also it has to show it, or it has to tell it is a free or it is nothing but the status is not free. So it has to tell. So those registers are also helpful in generating the code. See here, the operand descriptor, where the last value of the descriptor means the computed or the evaluated value what is present in the AREG argument register. So that is holded here, or that is stored here. So that can be the descriptor of the operand. What operand is there in the register, and what is the movement, whether the movement is from memory or whether the movement is from register. So that also it checks. And what is means it checks in the sense it checks the addressability. So I will just show you here how is the code is also generated for this. So you can also see the code generation for the respective example what I have taken here. So that is here. Now let me solve for the let me evaluate for the right operand. The right going to the right operand, as it goes to the right operand, it can see again the expression. It can see again the expression. So that expression by is again defined by left operand and the right operand. Sub expression, this for this it is treated to be as the sub expression. So here again it is having the multiplier, and what is its right operand and left operand? It's a right operand, sorry, first I need to solve the left operand. So the left operand of this is C. The left operand of this is C, and the right operand of this is it is C. Left operand is C, and the right operand is D. And the right operand is D. Now here, actually here it produces an intermediate code during the formation of the left evaluation. That intermediate code is nothing but the T, this T1. And here the intermediate code is nothing but, for C multiplied with D, the intermediate code is nothing but T2. The intermediate code is nothing but T2. But how does the compiler does, where I have calculated T1 is equal to, I have up to T1 A star B. I have up to T1 A star B. My simple expression, sub expressions, and P2 is equal to C star D. C star D. As per our code, sorry, as per our algorithm, what is the algorithm given? The algorithm given, the identifier, the passing action is something like this. The identifier, first it sees the identifier A, and that identifier is nothing but, it is a first, it is a first terminal, and I mean it is a first literal value. That literal value, how it has to be computed, it just it just scans and puts that into the descriptor, and actually B also just scans and puts that into the descriptor. And here T1, this T1 is nothing but, it is nothing but our the calculated or the evaluated value, which is multiplied with F2, where F2 is having something like B. So here what is happening means, the register which is holding the value of A, or which is holding the value variable of A is being moved to the register. Actually I told in the previous class, the compiler tried to use only one register. The compiler tried to use only one register to become more efficient. If it is using n number of registers, so again the memory utilization, or again the memory utilization during the runtime may increase. So that is what, as far as possible, it should minimize the number of registers. So that is what it tried to use in that way. So here right now at this stage, what is the code generated means, the code generated here, it is, here it has to load in as per our as per our syntax tree, it has to load a, where load a where this A is loaded, this A is loaded into some register, so it has to get loaded into some register. Therefore here at this part, what does it says, instead of saying load, because load and store uses in more traditional compiler languages, so here I'm just using move R, so that what we can understand as per our 8086. So move R, what is the code generated here? The code generated between during this period, move R, which register? Move A into register A. Move this A into register A. Actually, I try to use the capital as per this book, as per the book. So I need to use the capital here. A indicates as the identifier, as your identifier. So move this A identifier into register A, into register A. Next, what we need to do? Next, we need to multiply MULT, mult, this register with what? Multiply this register with B. And right now, the result. Where is the result? The result of T1. Where is the result? The result of T1 is in AREG. The result of T1 is in AREG. The result of T1 is in AREG. Now next sub part of the code, another for this I just try here itself so that you can understand. This is for our level of understanding. Now here the code finishes here only. Just see this. The code finishes here only. At the stage called as 3. Build descriptor will be at 3. Okay. Now moving to the next term. So the next term starts at the 3. Why 3? Because we have made the every individual computed value as T1. Whatever it is being stored into the, before getting stored into the register, we made that as T1. Now here move R. Again, how I can take AREG register? How I can take AREG register? So I need to make it free. I need to make it free. How I made it free? So I need to move the content of the computed value of this multiplied. Move the content of this computed value in some temporary, that is nothing but intermediate register. Move the content of this AREG into some memory location. Into some memory location. For some memory location, how we have denoted? Just see here. We have denoted here as move as the addressability is from memory. Why? Because we are with respect to memory. First A is there, no, that's what memory with respect to memory. Therefore, A is there and therefore B is there, and both are multiplied. See here, temporary. We need to add or we need to push the multiplied result into temporary register. So how we can push the result into temporary register? By making use of the TMP, by making use of the variable calling TMP, which is nothing but an another intermediate code. It is nothing but an another intermediate code. So that makes the free of the register. That makes the free of the register. So here I can move that into move M. I must say here move M. Why move M? Move the content of the register to the memory location, something like uh, T1. I must say as temp1 here, something like temp1. now. So now who is free? The content of AREG is pushed onto the memory location, that is temp1. Now again the memory is free. Sorry, now again the register is free. So what I need to do for the other part? For the other part, I can say as move, not move. So move R, because now register is free. Move in this register. In this register, the content of C. Content of C. Now next, move. Sorry, multiply the AREG register with D. AREG register with D. Everything I'm taking in capital, where the literals here are denoted by small letters. So the same small letters I have just denoted here by capital. Okay. Now here the multiplied result is in D. The multiplied result is in D. Now how the code will be generated? For this, it is at memory to register. So here the addressability is registered. Here also the addressability is registered. Here also the addressability is registered. But at last, it is in between. In between here the addressability is memory. So here the first step, second step, third step, fourth step, fifth step. Again I need to move at last. If you see here the code, at last again I need to move to the addressability is C and D. So the last value is in AREG register. So this is how the operand descriptor, and this is how actually here it is shown, the parse tree is shown very sub expression wise. Here it is taken together, but here also this E should be added with E and T6 should be joined, should be added, so that should be added in the sense this whole thing becomes as the sub expression. This whole thing becomes as the sub expression. So therefore they need to be evaluated. So this is how, and how is the status, and this is how meanwhile the code is generated. Now to optimize still the code, how, in what way you can optimize the code? It will be better if I take down also. So this is how. Now how we can catch hold the temp value as it is in temp now. Again we need to move this computed value, this temp to be added with the last, temp to be added with the last. So both will get added, both the resultant will get added. So the computed value of the sub expression 1 is in temp, and the computed value of the second sub expression is in AREG. So I need to move that's what. Now I will get the sixth step. Move the uh, move the temp or move the, but both now we need to add. So what I need to tell, not move, I need to tell here as add, add to this AREG, add to this register the temp1 value. Now the final computed value is in the expression add. is in the expression add. So this is in the expression add. So it is in register ARG. So this is the term 1, term 2. The term 1 here, how does it loads A and how does it loads B? Loading in the sense here, how does it moves into the register, that I have shown you here. Yes, have you understood? Yes, Onkar, abstract syntax tree, have you understood? Yes. So this is how the step which I have shown you here. The same thing at the sixth step, add AREG to temp. So here also I have just added it to this register the value of the temp. As all of you, have you understood how is the abstract syntax tree? Now another example I'll be giving. 1 plus 1 plus 2, 1 plus 2. This 1 plus 2 is nothing but an expression. 1 plus 2 is nothing but an expression. And here what is the expression? And here expression is plus. Expression is plus. And for this plus, what we call? We call it as the binary expression. Binary expression. And what is the here type? What is the type here? The type here, the type here it is called as which type of binary expression? The type here it is plus. And what is the left value? Left value is nothing but left value is nothing but the literal expression, and that literal expression is nothing but 1. I have here 1. And what is the right value? The right value is the literal expression, and that literal expression is nothing but here 2. It's nothing but here 2. And how the abstract syntax tree is constructed? The abstract syntax tree is constructed based on the expression given. And here the expression given equal to is, or the expression which is given here is nothing but the plus, and this plus so here it is called as 1, and the and the right sub expression is 2. And how does it compute the value? How does it evaluate the value? The value to be evaluated. The value to be evaluated here, actually here the expression is plus. Uh, Actually the expression is plus, and how does it gives into the how it is computed? How it is computed in the sense, it loads this value into the register. It loads this value into the register. Now here also it will tell the same thing. Load one into load one in the sense move one into register, and to that register add two. Now the value is just stored in the register itself only. So from the register we need to pick back. To pick back again, I must say same as of this command. We need to use somewhere the variable. That variable is nothing but the identifier to hold the result. To hold the result. So it can store into the memory addressability. So that it can store into the memory addressability. So here for this last part, the register is memory. The last part, the register is memory. For this part, the last part, addressability is memory here. Addressability is memory. And here, the addressability is register. Here also the addressability is register. Here, the third code or the third statement of line of code, the addressability is here memory. The addressability is here memory, here also the register, and here also the register. As I was saying here, if you observe here, what is the type? I said here the data type is int and 1. Int and 1. What is this? If you observe, for all the move instructions, for load and store it is only 1. For load and store it is 1. But as it all depends on the machine or the compiler, what they have kept in that, the type of the instructions, or the type of the instructions, for that what is the size. So if the size, if they have the higher versions of the size, so as per my knowledge, what knowledge in the sense, the as per the Dhamdre book which I have referred in that, so it is said that for all the move instructions and load and store instructions, the data type is 1. The data type is 1. As you can go with the different type of the instructions. So like move, mult, add, sub. So till there the type of the data type is only 1. Memory word is of only 1. Sorry, size is only 1. So this is how the operand, every operand need to be described. So we have the operand as per this example, it is A and B. And here, till here it will be called as the partial state. Why it will be called as partial state? Because it has to store this into the memory. Still it is holding in register. So as per as the data or the computed or the evaluated value, if it is in register, we can't see, it cannot load that into the memory unless and until it has some variable, or it has some identifier. So that identifier needs some recognition like addressability of the memory, and it has to get the addressability, then only the value will be computed. So till here, therefore it is called as the partial value. Yes, have you understood? Onkar, are you there? Now at the same time,
जी
if
मैडम
you
देख रहा हूँ।
now at the same time, can anybody tell if you, now this was one part which I have gone with the one expression. If you go with for loop, what it has to do, for loop में कैसे होता है, what it has to do. Second example, if I go with for example, if you go with the code called as for is having three expressions again. Something like I will take something like initialization I will be doing here, I is equal to 0. Then something, another condition I will be giving, some I is less than, or it can be equal to something like n. Another condition I would like to take like expression, something I can take for incrementing the value of I as far as. So we know that this is the syntax of the for. Now this for is treated to be as the expression. Now what is the expression? For is the expression. For is the expression. Now after a for is an expression. So for is having the three statements. So those statements, now what I can call it as the condition. What it is? Conditions. What are the conditions? Again, the conditions again, it reaches to the first root, that is expression. It reaches to the same. First of all, the for is an expression. Again, for is a condition. For is a condition. Once it sees the left bracket, and once it before ending to the right bracket, before seeing the right bracket, it assumes, the compiler assumes that it is a condition. Once it assumes that it is a condition, so what it will see? It will see the type. Now what is the type? It will see for the type as expression. Again, expressions. Again in expression, once it is assumed that it is an expression, so again what is the type? The type is, see how the parse tree is going backtracking, how it is going and fetching the same type of the action replay action. So again it will get here the type. So that type, what it is seeing? It is seeing something like assignment. It is seeing something like assignment. So once it sees the assignment as the equal to, assignment as what? Assignment as equal to, then what is its left value? What is its left value? And the left value, which is said to be as the expression, literal expression, the left value which is treated to be as the literal expression, and the literal expression here, the left value, which is nothing but the operand. That operand is I. That operand is I. And what is the right value? What is the right value? The right value of this equal to, the right value of this equal to is again a literal, is again a literal, and what is its value? Its value is 0. Its value is 0. So from this part, now here the type expression, once it sees the left far, it assumes that there are the three sub expressions. When it sees the condition, it assumes that there are the three sub expressions. So the first sub expression is finished here. So it will make here as the type 1. The first sub expression is finished here. So this loop or this parse tree will be repeated for different operand, will be repeated for different operand. So I must make here as the type 2. In type 2, again, actually, sorry, this is I. In type 2, again, what it will see? It will see as the assignment, not the assignment. If I remove the equal to, but if both are there, what would be the case? Both it will take together. So let me go with less than. So what is the assignment here? It cannot call it as assignment. It will call just as an expression. Uh, I must be very wrong here to tell it. Of course, it's an assignment, but it is an expression. Every time this is repeated, this is called recursively. So this is an expression. So what is that expression means? Again, you can come to know that it is an assignment. That it is an assignment. So here in the second statement, in the second statement, it is nothing but I have just taken here less than. So the type is less than. Then what is its left value? What is its right value? Left value is I. What is its right value? Right value is n. So with this, again this sub expression, this part of the sub expression is evaluated. How many sub expressions became here now? The sub expression from here, it became 2. This is the sub expression 1, sub expression 2. So this is how it is also called as 3 address. In the previous example also, it was called as 3 address only. Why it was called as 3 address? Because this sub part was evaluated one expression. This sub part was evaluated another expression. Assume that this is in T1, this is in T2, and the result is in T3. Whole T1 plus T2, T1 plus T2, it is in T3. It is in T3. So so this type of intermediate code generation where it is taking a 3 address, where it is taking a 3 address code, 3 address code. Now here also it is taking a 3 address code only. So this is expression 1, expression 2. So from here expression 2. Then now it will check for type expression or the statement 3. What is the statement 3 again? Expression, and that expression is incrementing. That expression is incrementing. So here we know that very well. Incrementing is something like which is equal to I is equal to I plus 1. The initial value of I, again it is added by 1. Again it is added by 1. So here also it is nothing but again the left value and the right value. So here I is equal to calculate the left value and right value. Again plus is nothing but the expression. Plus is nothing but the expression, and the left value of the plus of this expression is I, and the right value of this expression is 1. So both are added here. Again intermediate result, intermediate code is generated. Intermediate code is generated and it is loaded here itself. Right now it is here only. Later it is assigned to some, not assigned here, no, not requirement of any extra register here, sorry, any extra identifier, because here itself is I itself is acting as the identifier. So it is evaluated and it is just assigned to I, just assigned to I. So in this way, not only this, so all these three are for All these three are for loop, for loop, but it is not yet completed. Still, it has to come to the next part where it can see the body of the, where it can see the body of the loop. To calculate or to evaluate the body of the loop. Now, what it can tell? Again, it can tell the body of the loop. Second one, it will be again the type expression, or as I said here, the condition. First, it was here whenever it sees the for loop, it was seeing the condition. Now here it has to see the body. In body, again, what it has to see? It has to say some several equations, or some several whatever the in for loop it comes. Say for example, in for loop I am opening the for loop and I am assigning something I is equal to a, the last computed value I am assigning something to a. So in this way, the body of the loop gets end. In this way, the body of the loop gets end. But this cannot be only till here only. Now you know very well that how the coding will be based on the coding. The body of the loop is, so the body of the loop will make it as the expression and then it executes. So here even a single dot also is treated to be as an expression, and that dot also goes under the lexical analyzer. If after lexical, if that dot, say for example, dot comes under something like something like in pointer, making use of the pointer, this operator, and the dot is also used in Java in most of the cases, like in a system.l and print. So in that during that period, and what is the sense of the dot? So it all depends on the type of the language what you are making use. Even say for example, here I was using the semicolon. So where is the semicolon exactly has to be used? So that is all it does by the lexical analyzer. It is all does by the lexical analyzer. What after lexical analyzer only these all code generations are done. These all code generations are done. So this code generation, uh, it goes on generating the code, and later after code generation, a stage comes where any dead code, any unwanted code has to be removed during the time of the target code generation. During the time of the target code generation, and after that it just get loaded into the memory for execution. So I hope, have you understood all of you? Yes. To speak on this compiler, it is lot more. I don't think this online telling from far away, remotely, that is that much. I won't be able, whether I am justifying or not. I don't know. I need here exactly the pen and not pen, chalk and the blackboard. So that would be more better. So it will be difficult only for you to analyze here. Yes, understanding. If you have the knowledge of the abstract syntax tree, I hope all can understand. Have you ever studied the abstract syntax tree? Yes. Have you ever studied the abstract syntax tree? Am I audible to all of you? Yes. Am I audible to all of you? Pratik? Yes. Onkar? Prashant is there?
जी जी जी
हाँ, समझ में आया उनका।
जी बिल्कुल।
हम्म। ऐसे ही इफ को भी रहता है, और क्या क्या रहता है व्हेन वी बिल्ड द बेसिक ब्लॉक। मैंने तो इतना ही बोल दिया, और क्या क्या रहता है। मैंने कहा एक्सप्रेशन, सबको बोल दिया एक्सप्रेशन। जो भी लाइन, जो भी स्टेटमेंट रहते हैं, फर्स्ट ऑफ ऑल वी शुड ट्रीट देम एज एक्सप्रेशन, और एक्सप्रेशंस में ह्यूमन अंडरस्टैंडेबल एक्सप्रेशन। और क्या क्या रहता है, जैसे जब भी आप कुछ कोड लिखते हैं, क्या क्या किस मदद से लिखते हैं, क्या मीन्स बेसिक बिल्डिंग ब्लॉक रहना चाहिए ना उधर। क्या क्या रहता है, सभी बेसिक बिल्डिंग ब्लॉक को क्या ट्रीट करता कंपाइलर, उसको बोलता है ऐसे ही ट्रीट करता, पार्स ट्री के हिसाब से ही ट्रीट करता है, पार्स ट्री जनरेट करता है। जैसे ही पार्स ट्री जनरेट करता है, वो समझ लेता है कि कोड कैसे जनरेट हो रहा है, इसको कोड कैसे जनरेट हो रहा है। जैसे ये ए लिटरल है, ये ए लिटरल को क्या करना चाहिए उसको समझ में आता है। ये पार्स ट्री हो गया, ये पार्स एक्शन हो गया। पार्स एक्शन के वक्त यही कोड है, ये कोड को हम बोलते हैं इंटरमीडिएट कोड। क्या बोलते हैं, इंटरमीडिएट कोड। ये इंटरमीडिएट कोड कब कब हो रहा, लेक्सिकल एनालिसिस होने के बाद। पहले सिंटैक्स एनालिसिस होता, हाँ, फिर उसके बाद लेक्सिकल एनालिसिस होता है, फिर ये क्या है, पार्स। पार्स, ये सिंटैक्स को ही हम बोलते हैं, सिंटैक्टिकल एनालिसिस को ही बोलते हैं पार्स ट्री। सिंटैक्टिकल एनालिसिस को ही बोलते हैं पार्स ट्री। लेक्सिकल एनालिसिस मीन्स एक एक टोकन को डिवाइड करते जाता है। कुछ भी देखे तो उसको समझ में आना, ये क्या है, मैं इसको कौन सी कैटेगरी में डालूं, और इसका मतलब कैसे निकालना है। तो जैसे ही वो एंड ऑफ दैट लाइन और एंड ऑफ दैट स्टेटमेंट के पास आ जाता है ना, तब उसको समझ में आता है, ओ दिस इज द मीनिंग। जैसे ही मीनिंग जनरेट होता है, पार्स ट्री जनरेट करता है, जैसे पार्स ट्री जनरेट करता है, उसका इंटरमीडिएट कोड जनरेट होता है एक एक। उसका इंटरमीडिएट कोड जनरेट होते ही फिर अगला स्टेप रहता है। अगला स्टेप क्या रहता है बोले तो, फिर इसको ऑप्टिमाइज कर लेता है, स्टैंडर्डाइज करता है, कौन से अनवांटेड कोड है, किसको निकालना है। तो वो ऑप्टिमाइज कर लेता है, स्टैंडर्डिटी बना लेता है। फिर स्टैंडर्डिटी बनाने के बाद उसको बोलते हैं हम ऑब्जेक्ट कोड, उसको बोलते हैं ऑब्जेक्ट कोड। अभी फिलहाल ऑब्जेक्ट कोड रेडी है कि एग्जीक्यूट करने के लिए, लेकिन उधर लोडर और लिंकर भी रहना चाहिए। लिंकर लिंकर क्या करता है, जो भी बहुत से लाइक जावा में डॉट क्लास फाइल्स रहते हैं, और डॉट क्लास फाइल्स के हिसाब से उसको जो भी लाइब्रेरी फंक्शंस, जो भी उसके हिसाब से सपोर्ट चाहिए उसको रन करने के लिए, तो सभी को ढूंढ लेता है linker. So it will link all the files together what it wanted to run. Then तब जाके लोडर का हेल्प लेता है, उसको जाके मेमोरी में लोड करना है। जैसे ये लास्ट वर्ड कोड हमने जैसे देखा ना, अनलेस एंड अनटिल ये रजिस्टर कुछ मेमोरी एलोकेशन में लोड नहीं होता, वो मेमोरी एलोकेशन रजिस्टर को तो हम मेमोरी एलोकेट नहीं कर सकते, सॉरी। तो हम वो रजिस्टर का कंटेंट को हम किसी एक वेरिएबल में लेना चाहिए, और वो वेरिएबल जाके मेमोरी में बिठा लेना। वो उसको रिकॉग्नाइज करता है कंपाइलर, कुछ एड्रेस देता है, हाँ चलो भाई मैं आपको पहचानती हूँ बोलकर वो एड्रेस दे दैट इज कॉल्ड एज एड्रेसेबिलिटी। सो वो एड्रेस पे और वो वेरिएबल सॉरी वो एड्रेस पे कौन सी चीज है, जैसे टेम्प 1 है, टेम्प 1 में कौन है भाई, कंटेंट क्या है, तो वो कंटेंट कहाँ किस वक्त कैसे हम रिट्रीव कर रहे हैं, प्रिंट यूजिंग आईओ स्टेटमेंट से, प्रिंट आउट सॉरी यूजिंग आउटपुट स्टेटमेंट से हम उसको बाहर लेकर उसको देख रहे हैं क्या जनरेट हुआ। इतना सारा काम आईओ करता है। ये ये आईओ करने से पहले मेमोरी क्या बोलते हैं हम, मेमोरी इनपुट टू मेमोरी इनपुट आउटपुट। सो मेमोरी इनपुट आउटपुट के वक्त ये मीन्स मैपिंग के वक्त हमको रिजल्ट दिखाई देता है, उसको ही हम बोलते हैं रन टाइम। इसको ही हम क्या बोलते हैं, रन टाइम। यस, रिमेनिंग स्टूडेंट्स, कैन यू टेल इज देयर एनी अदर एक्सप्रेशंस फॉर कोड generation? Yes, today I have shown like blackboard only because in the last class I was just displaying the figures of the textbook. Okay, have you understood, other students? कोई बोलते नहीं ओमकार के अलावा। प्रशांत, प्रणाली, प्राणेश, आप तो बोलिए ना, पहले आप बोलते थे। प्रीति, मधुरा, योगेश, योगेश अंडरस्टैंड हो रहा? गीता, सिद्धि, श्रुति, काजल, प्रीति, प्रशांत, कितने लोग टेस्ट नहीं करे पिछले बार का? कोई एक बोल रहा था, मीन्स once one of your classmate was telling that he has not attended test. Yes, may I know you all are understanding? And more, some of the students have requested me to upload the link in the previous, in the last week. I think still 7 students are absent. Why 7 students who has not written the test? So still 7 students have not done, not 7, 8 students. Why you have not done? Who are those? I hope those 8 students were absent, but still I have uploaded in the group, SP group, na WhatsApp group. We should not do like this. So there are only 63 response because one is excluded, and that student has also requested that to give another chance. But if you operate with the mobile, one chance, and with your desktop, another chance. Maybe again with your lappy, another chance. I have not made to the device oriented because here that's in Google Chrome that was not there. Device oriented. It was only the number of time what you log in different type of the devices. So based on the machine, you will get the response. But if you operate in the same machine, you will not get the response. Yes, understood. Geeta, Yogesh, Neha, Prashant, Manashri. Nobody is responding. One is there. Two,
Present,
three.
ma'am.
Present, ma'am.
Understood.
Yes, ma'am.
Okay, one have is not there. Where is one? One is absent, no? Okay, I'll treat it as absent. One is absent. Then four,
Four
five,
present, ma'am. Present, ma'am.
six.
Present, ma'am.
Understood. Six.
Yes, ma'am.
7,
Present, ma'am.
8, 9, 10, 11,
Present, ma'am.
12, 13,
Present, ma'am. 13.
14,
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present.
21,
Present, ma'am.
22,
Present.
23,
Present, ma'am.
24,
Present.
25,
Present, ma'am.
26,
Present, ma'am. 26.
okay, 27, 28,
28. Present, ma'am. 28.
29,
Yes, ma'am.
30,
Present, ma'am.
31, 32,
Present, ma'am.
33, 34,
Present, ma'am.
35,
35 present, ma'am.
36,
Present, ma'am.
37,
Present, ma'am.
38,
Present, ma'am.
39,
39. Present, ma'am.
40,
40 present, ma'am.
41, 42, 43,
42. Present, ma'am.
43 present, ma'am.
44,
Yes, ma'am.
45, 46,
Yes, ma'am.
47, 48,
47 present, ma'am.
Present, ma'am.
49,
Present, ma'am.
50, 51,
Present, ma'am.
52, okay,
51
52,
present.
52, 53, 54,
Present.
55,
Present.
56,
Present.
57,
Present.
58,
Present.
59, 60,
Present.
61,
Present, ma'am. 61.
62, 63, 64,
Present, ma'am.
65,
Present.
66,
Present.
67,
Present.
68,
Present.
69,
Present.
70, 70. Absentee list I'll be reading: 1, 12, 27, 31, 41, 45, 50, 52, 62, 63, 70. Is that okay?
66 present.
Okay. Anybody? Anybody else? Hello? Okay. Today I'll be posting the handwritten notes, but still the compiler has not finished. Just I will post so that you can check it out. The handwritten notes. Still, I have to take compiler. Another some topics are there on compilers, memory allocations, dynamic memory allocations. So that will be continued in the next class. Till then, thank you. Thank you all.
Hello, ma'am.
Yes,
Roll number 41.
roll number.
41.
Huh. Anybody else? One is not there. Pratik Yadav. What's your roll number?
70.
Why you were absent? Huh?
Ma'am, due to network connection, I lost it for 30 minutes.
Hmm. Okay.